Here's the plan. I'm going to start by looking at which refrigerants are flammable and then talk more about flammability and the other safety hazards, a little bit about how to work safely in your safe working environment, and then most of the time I'll spend looking at the safe working procedures and the equipment that you might need that's different from working with flammable refrigerants. So the flammable refrigerants are all the hydrocarbons and some of the HFC type refrigerants, the hydrofluorocarbons. So here we have a list of the most common. On the left-hand side, we have the higher flammability refrigerants, R290 propane, 1270, which is propene or propylene, and R600A, which is isobutane. And then on the right-hand side, we've got R32, R1234, two variations of that, ZE and YF. And then we've got several blends. So the ones on the left are all the hydrocarbons. They have higher flammability. I'll explain what that means later on. And the ones on the right are all HFCs, so they're flammable HFCs, and they have lower flammability and also are known as A2L refrigerants. Again, I'll explain that later. So why do we use them? Basically, we use them because of their very low environmental impact. They all have, in the case of the hydrocarbons, extremely low global warming potentials, or in case of the flammable HFCs, they have fairly low global warming potentials, but all much lower than the non-flammable refrigerants. And we also use them because they're very good refrigerants. In particular, the hydrocarbons perform very well as refrigerants. We use them primarily in systems where the charge is limited. So R600A is used in all of our domestic appliances. The other hydrocarbons, R290 and R1270, are used in commercial plug-in appliances like this, but also in fluid chillers, which are outside in outside air, and also things like heat pumps. R32 is used primarily in split air conditioning and some larger air conditioning systems as well. The blends are used primarily in retail refrigeration. You won't see them being used in very large central plant systems, but they're used in smaller central plant systems, typically with large condensing units or very small packs. And also they're used in some heat pumps. 1234YF is used in vehicle air conditioning, and then the ZE variation is used in a few fluid chillers. But these two are also used as blend components in these blends here in some cases. But the most important thing about this is that the flammability limits how much refrigerant we can use in systems, and also means that there are changes in the design of some systems, in particular around things like sources of ignition and ventilation. A little bit more about the hydrocarbons, because of course we use these hydrocarbons as a fuel. So it's a bit odd that they're also really good refrigerants, but they are. But the version that we use as refrigerants are very high purity, much higher purity than the ones we're going to burn as a fuel. And also they're not stench, so they're odorless, again, like many other refrigerants. They also go by a trade name CARE, which is the BOC trade name. Different compressors are used for R600A. We have to have a bigger displacement compressor when we're using 600A, so they are quite different to the one that you might have used for R134A, for example. And another big difference is that the density of hydrocarbons is a lot less than the density of an HFC. If we look at an example of that, the old Ball's ice cream cabinets used R134A and used 216 grams of 134A, but the ones that now run on R290 propane use only 90 grams of propane to do the same job. So that's an example of the density difference in action. And of course we also have to think about that when we are filling recovery machines, which I'll talk about later on. So how do you identify if a refrigerant is flammable? The first thing is there should be a flammable gas sticker on the system, but also if you look at the Danfoss refrigerant slider and look at the refrigerant, then if you click through to the last page, that will tell you what the safety group is, and of course if it's flammable it will have a lower flammability level and an auto ignition temperature. And then looking at the cylinders will have again a marking on it on them that show that the refrigerant is flammable. So that's the pictogram that you'll see on the cylinders. The cylinders are different with hydrocarbons, and in particular the valve arrangements, but unlike other refrigerants, the non-flammable refrigerants, we are allowed to supply hydrocarbons in small disposable cylinders. Otherwise you'll get all these flammable refrigerants in the larger cylinders as well. The most important point really about this is that all of the cylinder valves, regardless of what size of cylinder and where it comes from, all these cylinder valves are different to the standard valve that you use on other non-flammable refrigerant cylinders. Cylinder storage and transport is very like other compressed gases. When you're storing the refrigerants, always store them with the valves capped, and always the flammable refrigerants store outside if at all possible. You need good ventilation in your storage area. Transport is in accordance with the international ADR regulations. You're almost certainly going to be below the threshold of those regulations, in which case you need an awareness of the hazards of what you're carrying. The vehicle needs to be ventilated. You should carry a 2 kilogram dry powder fire extinguisher. Make sure the cylinders are secure, obviously not having the adapter on there, the valves closed and capped, and display a flammable gas warning diamond on the outside of your vehicle. So let's look a little bit more at flammability and the other safety hazards. You need three things to arrive at combustion. You need a flammable gas, which is obviously your flammable refrigerant. You need oxygen, which is in the air, and you need a source of ignition. The flammable refrigerant and the air has to be in a certain mix to be flammable. So we'll have a look at that in a little bit more detail. And what we've got here is something that's showing you the buildup of flammable gas in air and where it is actually flammable. So here you've got no flammable refrigerant, 100% air. And as we come along here, you're building up the flammable gas until at this end, you've got 100% flammable gas and no air. And the flammable range is here. So below that, you've not got enough flammable gas, and above that, you've not got enough oxygen. This point here, where you've just started to get a flammable mix, is called the lower flammability limit, and this is the upper flammability limit. So this here, the lower flammability limit, is quite important when we're looking at how flammable refrigerants are, for example, because the lower this is, you could say that the refrigerant is more flammable because you need less of it to get to a flammable mix. So earlier on I mentioned A2L and A3 refrigerants. This is part of the safety classification for refrigerants, which looks at two things. It looks at toxicity and flammability. So all the A refrigerants have lower toxicity and the B refrigerants have high toxicity. The only one that we use is ammonia, which is a B2L refrigerant. And then the 1, 2L and 3 denote the degree of flammability. So A1 refrigerants are non-flammable, A2L refrigerants have lower flammability, and A3 refrigerants have higher flammability. And we determine whether a refrigerant has lower or higher flammability by looking at a number of different things. The first thing is the lower flammability limit. So the lower that is, the more likely it is that that refrigerant will be a higher flammability refrigerant. So if the lower flammability limit is less than or equal to 3.5% refrigerant in air, then it's going to be in the higher flammability category. We also look at heat of combustion. The more heat of combustion is produced, the more likelihood is that that refrigerant is in the higher flammability category. And then we look at flame propagation, how fast a flame moves once the refrigerant is ignited. And to get into the lower flammability category, the refrigerant has to move at less than, the burning velocity is less than 10 centimeters a second. That's walking pace. So that is the third difference between the 3 classification and the lower flammability 2 classification. So looking at the flammable range in a little bit more detail, I've included acetylene on this just to give you an example of something that you ignite readily when you're brazing, for example. You can see that the flammable region for the refrigerants is quite a bit less. So the lower flammability for the A3 refrigerants, the hydrocarbons, is typically 2% to 10% as the upper flammability level. Whereas for the A2L refrigerants, the lower flammability is quite a bit higher, anywhere between about 6% up to 14%, depending on the refrigerant. So, as I said earlier on, for it to be an A2L refrigerant, it needs to have a higher lower flammability level. You need more of this refrigerant to get to a flammable mix. And then we come on to sources of ignition. A naked flame is always a source of ignition, whatever the refrigerant, whether it's A3 or A2L, whereas an electrical switch that can arc and spark, that will almost certainly be a source of ignition for an A3 refrigerant, but it's extremely unlikely that it will be a source of ignition for an A2L. So naked flames like brazing torches, matches, cigarette lighters, all sources of ignition with A3 and A2L refrigerants. And then the electrical sources of ignition for A3 refrigerants include any unsealed electrical switch which can arc or spark, so on-off switches, for example, contactors, and also, of course, just pulling a plug out of a live socket will give you a spark. And then things that we use on refrigeration systems like pressure switches, relays, Clixons, that type of thing are likely to be sources of ignition as well. And then switches on our equipment that we use, like vacuum pumps and recovery machines, are likely to be sources of ignition, as are possibly electronic leak detectors that we're using for non-flammable refrigerants. This one, for example, has a heated diode under here, which could potentially be a source of ignition. There are a lot of electrical devices that are not sources of ignition, and they will be EX rated because they will have been tested to the relevant standard to ensure that they will never be a source of ignition, whatever the conditions are. So you will see an EX rating on lots of components like fan motors, relays, etc. So only if a device is EX rated do you know that it's not going to be a source of ignition. The other safety hazards of hydrocarbons and the other flammable refrigerants include explosion risk from accumulated refrigerants, and also, like the other refrigerants, liquid burns because they're all low boiling point substances. Propane, for example, boils at about -40 degrees C at atmospheric pressure, so that will give you a freeze burn, and asphyxiation. They're all odorless and heavier than air, so they accumulate at low level. There's nothing in them to sustain life, so they will asphyxiate you exactly the same as the other refrigerants. One other thing to talk about with regard to safety is burnt HFC, also known as HFOs in some cases. If you burn an HFC, you get hydrogen fluoride. If that is in contact with moisture, for example, in your mouth, then that forms hydrofluoric acid. That's extremely toxic. It makes you choke, etc. And if you're affected by this, you need to get into the fresh air immediately, and you might need medical attention. So it's really important when you're working with HFC systems that if you are using a brazing torch, for example, and you're likely to get burnt HFC, that you work in a really well ventilated area. And that leads us on to talking about working safely. So, two key points here about your safe work area. One is it needs to be very well ventilated, and the other is that there should be no source of ignition within 3 meters of your work area. So that includes naked flames that you're not in charge of and unsealed electrical switches. In addition to that, you should be wearing gloves and safety glasses, and you should have a dry powder or CO2 type fire extinguisher in your work area. I just want to give you an idea of what a very small charge of a flammable refrigerant could look like. So what we're looking at here is something that would fill to 90% a standard Coke can. So 300 millilitres of R290 equates to 156 grams of the refrigerant. If you let that go, it obviously turns into gas, and it will fill this sort of volume. So we're looking at a volume of 1.5 meters radius by about 0.5 meter high. That is the volume of the flammable mix that you could get if you release or let go 150 grams of R290. So it fills a large volume with a flammable mix. Obviously, it's not going to be quite that simple, because hopefully it will disperse because you're working in a well-ventilated area. But if you're not, that is what can happen. So a small amount of liquid R290 and other flammable refrigerants fills a large volume with a flammable mix if you let it go. That means that ventilation, of course, is really important if you're doing invasive work on refrigeration systems. So you need a through draft. Make sure that you've got doors and windows open, and if necessary, introduce forced ventilation by using something like this Care Air fan. This is good because it's got no sources of ignition on the fan itself, on this little box. You've got 5 meter extension lead. You plug that in well away from your 3 meter safe work area, and that's where you switch the fan on and off. The critical point here is preventing the accumulation of any flammable refrigerant. In addition, if you're working with hydrocarbons, then you should be using a hydrocarbon gas monitor. These are really readily available, and what they do is they alarm if hydrocarbon is present in the air, and they will start to alarm at a level of 20% of the lower flammability level. So they alarm well before you've reached a flammable mix in the air. So if you're working invasively on hydrocarbon systems, you should have that monitor switched on at low level while you're working. So it's really important that you follow those basic principles associated with your work area, and then you follow the safe work procedures. So that's what we're going to look at now. And this includes not only the procedures, but also the equipment that you'll be using. In some cases, that's different. So just to say that this is not a complete training course on service procedures. This is just showing what you would need to do differently if you're working with flammable refrigerants. We've talked about the work area, and we're going to look at equipment and procedures now. You'll have a risk assessment that shows you how to work safely for every activity that you do. It identifies people at risk, so you, for example. It identifies the hazards, flammability, and the other hazards that we've talked about, and it specifies the control measures, including things like the work area that we've talked about and the procedures. It's really important that you read and understand the risk assessment. So, a reminder about your safe working area. The area should be well ventilated with no source of ignition within 3 meters. You should have a fire extinguisher in your work area. If you're working with hydrocarbons, you should have a flammable gas monitor for invasive work, and you should be following normal principles such as wearing gloves and goggles. You'll need special equipment for leak detection. You'll need your gas monitor if you're working with hydrocarbons. You'll need a different recovery machine, one that's safe with flammables, and a different cylinder, and you'll need a different vacuum pump. Your access equipment will be standard. And of course, if you're working on R32, because this runs at a higher pressure than the other flammable refrigerants, you need to make sure that all the equipment you're using is suitable for the higher pressure. So the procedures we're going to be looking at are leak detection, recovery, evacuation, changing components, and this includes where you might be unbrazing, and then charging. So the first thing to look at with leak detection is the method that you use. It must be safe and it must be sensitive, and that means that you're not going to be using a standard HFC leak detector because it's neither of those things. But there are a number of leak detectors available. You could, of course, use simple leak detection spray, but there are a number of electronic leak detectors that are available for the different flammable refrigerants. Just make sure that you're using the one that is safe and sensitive for the refrigerant that you're trying to find. And then if we go on to recovery, refrigerant recovery, you need to use the right recovery machine. There are a number of them out there now suitable for A2L and A3 refrigerants. Just make sure again that you're using the right one. Read the specification of the machine. And make sure you're using the right cylinder for A2L and A3 refrigerants. They are slightly different. Don't mix the different refrigerant types in one cylinder. Make sure that they are marked for flammable gases and make sure that you fill out the waste transfer note correctly. One thing to bear in mind, as I mentioned earlier, is the density difference. What we've shown here is what the maximum fill weight would be for a traditional HFC 10 kilogram safe fill weight cylinder. Because of the density difference of hydrocarbons, you could only safely fill that cylinder with 4.5 kilograms of hydrocarbon or 6 kilograms of R32, again, because of the density difference. So it's really important that you use the right recovery machine and make sure it's correctly labelled with the correct fill weight and that you don't overfill these recovery cylinders. So just as an example here, looking at that slightly differently, this is a 10 kilogram cylinder with 10 kilograms of HFC in it. The same size cylinder filled with hydrocarbon will only weigh 4.5 kilograms. And looking at that in a slightly different way, this is a 10 kilogram HFC recovery cylinder, and this is a 10 kilogram hydrocarbon recovery cylinder. You can see it's a lot bigger. Another difference with hydrocarbons is that you are allowed to safely vent small charges. So as long as the charge is less than 150 grams of R290, R1270 or R600A, you're allowed to vent that so long as it can be done safely. That means it has to be vented to outside of a building where the air is moving to disperse the refrigerant, and not somewhere where it's going to drop down into a below ground area like the drains, etc. You are not allowed to vent HFCs like R32, etc. And you are only allowed to vent up to 150 grams of a hydrocarbon. We now look at evacuation. Again, you need to make sure you're using the right vacuum pump. So for A2L refrigerants, use an A2L approved pump. It will have a spark-proof motor and on-off switches. It will have a 5-meter lead so that you can plug it in outside of your 3-meter zone. These are not generally approved for A3 refrigerants. So if you're working with the hydrocarbons, you must make sure that you're using an A3 vacuum pump. Again, plug it into a socket outside of your safe work area and switch it on and off remotely. Make sure your area is well ventilated, and of course, because it's a hydrocarbon, you're monitoring it with a gas detector. And some of these vacuum pumps do come with an exhaust hose so that you can vent the gas coming out of the system to an area well outside your 3-meter zone. If we now look at component change, here what we're really interested in is that you unbraze safely. So general principles again, make sure your area is really well ventilated, wear suitable gloves and goggles, and make sure that you remove the flammable refrigerant from the system before unbrazing. And for hydrocarbons, make sure that you're using the hydrocarbon gas monitor. This is the really important point, that you remove the flammable refrigerant from the system before you unbraze. And I'm going to show you 2 procedures now, and you'll be following one of these to make sure that that's the case. So if you are recovering, if you're working on a system that's got A2Ls in it, or you can't safely vent the small hydrocarbon charge, or it's a larger hydrocarbon charge system, you're going to be recovering the refrigerant out before you unbraze. So the way that you would do that is recover the refrigerant until the system is under a vacuum. So perhaps run the recovery machine for longer than you would normally do until you're down onto a vacuum. Then introduce nitrogen into the system, so you're breaking that vacuum with nitrogen and fill it to a very slight positive pressure. And what you've done is you've diluted any remaining flammable refrigerant with nitrogen so that when you unbraze the pipework, you won't be igniting the flammable refrigerant in the system. So that's what you would do if you need to recover the refrigerant. If, on the other hand, you've got a small hydrocarbon system where the charge is less than 150 grams and you're able to vent outside safely, then that's the first thing that you would do. You would then charge nitrogen into the system. You'd vent that nitrogen hydrocarbon mix, and then you'd evacuate the system down onto a vacuum, break that vacuum with nitrogen, bring it up to a slight positive pressure, and then you can cut or unbraze the pipework safely. So you are again introducing nitrogen to dilute the remaining flammable refrigerant in the system prior to unbrazing. What I'm going to show you now is a video which goes through those procedures. Just trying to get the video to actually work, which it's not wanting to do. Okay, I'm sorry that the video doesn't work. We'll try and show that at the end, but basically what it shows you is that if you don't get all the refrigerant out of the system by diluting with nitrogen, then you will get a very large flame as a result of that, and that is something that obviously you need to avoid, because that can potentially be very harmful to you, and of course it can ignite everything around the system. It's important that you remove all the refrigerant from both sides of the system, so that if there is trapped refrigerant, for example, because you've got a block dryer, that you have access both sides and remove the refrigerant from the whole system. So you might find it necessary to pierce or puncture the filter dryer or cut the capillary tube. Make sure your solenoid valves are open. But some accidents have occurred because of block dryers in systems. In fact, probably most of the accidents that are associated with working on hydrocarbon systems and other flammable refrigerants have occurred because of block dryers and not getting all the refrigerant out of the system. And then when you're rebrazing the system up, make sure that you purge the system with nitrogen to a very low pressure. So you should just feel that outlet from the nitrogen on the back of your hand. And this is a couple of setups for actually achieving that. Obviously, make sure you've got an access point open to atmosphere so you don't build up nitrogen in the system. If you're replacing components on the system with any electrical device, make sure it's a like-for-like replacement. Make sure compressors are the right model, so again, like-for-like replacements, and then make sure that the system is clearly labelled with the flammable gas label, and that the charge weight is on the system as well. Another thing to remember if you're servicing these systems is to make sure that cables are not touching pipework. If that happens, then the cable wears like this, and you get contact between the live conductor inside there and the pipe. You get an electrical arc because of that. That will melt the pipe, refrigerant will escape, and that flammable refrigerant will ignite because of the arc, which will be a source of ignition. And that, of course, will cause a fire around the system. So just make sure that you've not got cables touching pipework when you finish servicing a system. If we now look at charging, this is very similar to charging other refrigerants. You're going to wear your gloves and goggles. Make sure your lines are empty before charging, so either purge them carefully or ideally evacuate the lines. If you are purging, then open and shut the cylinder valve before purging. Use short lines, because that minimises the amount of residual flammable refrigerant you've got in the lines, and also make sure you're using the monitor when you are charging hydrocarbons. Charge accuracy is important, especially as many flammable refrigerant systems have a small critical charge, and the density is also lower with many of these refrigerants, in particular the hydrocarbons, so the charge weight again is much less, and we're typically looking for charge accuracy of 5%. So on some of these systems that can be as low as plus or minus 5 grams. So you just need to make sure that your scales are that accurate. One way of doing that with these very lightweight disposable cylinders is to make sure that you've got a weighted valve on the cylinder, and that then makes the cylinder more stable on the scales, or use one of these nifty scales where you're connecting the cylinder directly onto the scales, and then you've got an outlet here. Everything is much more stable on that type of scale, so you'll be able to charge in more accurately. Make sure that you seal the system after you've done the charging and the servicing, and then do a final leak test on that system. And then a really important final point is not to retrofit non-flammable HFC systems with flammable refrigerants. They haven't been designed to run with flammable refrigerants, so you can't do that retrofit. And a summary of those procedures: make sure you work in a well-ventilated area and that area is free from sources of ignition. You need a 3-meter radius around you to achieve that. Use an appropriate leak test method. That could be soapy spray or the right electronic leak detector. When you're recovering, make sure you're using the right recovery machine, and make sure you're not overfilling recovery cylinders, that they're the right cylinder to fill. Use the right evacuation pump and switch it on and off remotely from your system outside your 3-meter safe work area. Remove all the refrigerant from the system and backfill with nitrogen prior to unbrazing. That's a really important point. If you're replacing anything electrical, including the compressor, make sure you're using like-for-like replacements, and make sure that you are charging accurately, especially these small charge systems. Thank you for listening to that. If you have any questions, we'll now be answering those. So thank you very much for listening.
Well, thank you for that incredibly comprehensive presentation. Jane, would you like to pop your camera and your mic on? I think that's one of the most comprehensive presentations I've seen in a very long time. I'm not sure. I have no questions for you. Um, so
Can I
was going
show
to
that
say,
video that
yes, I was
didn't
going to
work?
say, would you like, I'm just
Right.
going to stop sharing my screen. If you'd like to share yours, we'll pop
Thank
that
you.
up for everybody now.
Right, apologies that this video didn't work. That was actually the third attempt at the at recording. So at that point, I just thought we'll do it now. So the video shows you what happens if you don't remove all the flammable gas prior to unbrazing by following one of those 2 procedures. So in this case, what had happened was we'd vented the refrigerant from this system, but then not done anything more. And you can see how much residual flammable refrigerant there is left in the system if you just go straight to unbrazing. This is obviously done in controlled conditions. Steve knew what was going to happen. But if you do that under normal site conditions, unaware that there's a lot of flammable refrigerant left in the system, then that will cause major problems. In our experience of within the refrigeration industry of the accidents that have occurred with flammables, then that's probably the main accident that happens, because you're unaware that you haven't got all of the refrigerant out of the system. So that's why those procedures are really important.
That's great. Well, thank you. Right, what I'm going to do, if anyone does have any questions, please pop them in that question box and we'll get through as many as we possibly can. Let me just quickly pop out the chat box, and we have one come in from someone. Is there a difference between something that is EX and ATEX rated?
It's EX rated that we're looking for, because that means that the electrical device has been tested to the correct standard, the EN 60079 standard from memory. So those are the devices that we need. ATEX rating is slightly different. I'm not going to try and explain that right now, but it is EX rating that you need to look for with electrical devices.
Thank you. Somebody has asked a quick question about whether or not we will be sharing the presentations. Just to let you know, we will be doing that. You should receive the recording within about, I would say, within about sort of 24 hours. We're not actually able to share the slides, but you will definitely get that recording, and that will be emailed directly to you.
And when you get that recording, you can spot the deliberate mistakes, like me totally forgetting the difference between valves and adapters. I'm afraid I said valves many times when I should have said adapters.
Oh,
Apologies for
it's the
that.
pressure of the recording, isn't it?
Yeah,
You know in the minute. As soon as you watch it back, it's like when you spot those typos.
yeah.
It's a horrible, horrible feeling. But honestly, it was a brilliant, brilliant presentation. Um, so quick question that's come in. HC is absorbed into oil. How do you get this out? Do you leave it for a time period?
That is one of the reasons why you would need to ideally evacuate the system, or if you're recovering the refrigerant out, take the system down onto a vacuum and then replace that with the nitrogen. That's why you do that prior to unbrazing. If, for example, you had oil that you recover from a system, you would leave the oil can open, the oil container open, to allow the hydrocarbon that's absorbed into it to leave the oil. So yes, you do need the reason for evacuation or recovery down onto a vacuum is to try and get as much of that hydrocarbon or other flammables as possible out of the system, including the oil, prior to unbrazing.
Okay, so there's another question that's come in, which is we have different sizes of under-the-counter fridges. Is there any calculation to identify the charge in grams in case the nameplate is not available?
That's not easy to do. No, you would need to contact the manufacturer. There's no simple way of calculating the charge. I think it's worth actually that, it leads on to a really good point, and that is that in order to make sure that we design flammable refrigerants safely, there are several things that are different in the system, in the design of the system. And one is, probably the most important one, is that charge sizes are limited by the standards, either EN 378 or the product standard limits the charge size. And so we have some very small charge size systems. In all cases, the charge size should be on the nameplate. And if it's not, the only way to know what that charge size is to contact the manufacturer.
Okay, so we have another one that is, should electrical defrost in evaporators be required to have a lower temperature below the ignition gas point of the refrigerant in A2L?
Yeah, it would be with any flammable, it would be common that there should be nothing on the system that is within 100 degrees of the auto ignition temperature. I think in my experience, most defrost heaters would actually be below that temperature. But yes, a source of ignition is, I talked about naked flames and electrical devices, but hot surfaces that are within about 100 degrees of the auto ignition temperature would also be considered to be sources of ignition. Yes.
Okay.
So, yeah.
Okay, so I think we have a bit of a challenging one here. Mark Forsyth from the World Skills Show has just written in and said, we're using A2Ls R32 at the NEC exhibition as part of the World Skills fault finding. We can't extend a hose line across the halls. What ideas do you have for doing the evacuation process?
Make sure the area is really well ventilated. Would be my key point there. Ventilation is really important when you're working, well, with any refrigerant, but of course, in particular with flammables. So really make sure the area is well ventilated in that particular case. And that's not just for the World Skills Competition, that's for anybody working with flammables. Wherever you're working, ventilation is one of the key points.
Okay, thank you. We have one more that's come in that says, what should the suction and discharge pressures be for R290 and R600?
Well, that depends on the operating conditions. So it depends on the application. For example, on the high side, it depends on what the ambient temperature is and how big your condenser is. And on the low side, it depends on whether it's a high temperature or low temperature application. You would expect the pressures of R290 to be slightly lower than they would have been for the same system running on 404A. For R600A, the pressures would be a lot lower. And in some cases, for example, with frozen food applications, domestic freezers, you would expect the system to be running on a vacuum on the low side on R600A and on a very small positive pressure on the high side. But it's like any system. You can't determine what those pressures will be without knowing what the temperatures are and what the application is.
Thank you. Okay, we have one more, which is, can static be an ignition risk? Would it be worth getting anti-static PPE?
We have, in all of our experience, never found that that's necessary. No.
Excellent. I'm going to do one question for you. It's my favorite question, and I ask everybody who does the masterclasses. If people take absolutely nothing else away from this presentation apart from three things, what should their top three takeaways be?
I think from the point of view of safety, and that's after all what this presentation is all about. The top three things would be, when you're working, is to make sure that the area is well ventilated, which obviously came up in Mark's question. So make sure the area is really well ventilated, doors and windows open, get a through draft. If necessary, use one of the ventilation fans. When you're working with hydrocarbons, really invest in one of the hydrocarbon detectors. It's different from a leak detector. This is actually monitoring the air continuously. They're really readily available from somewhere like Amazon. Others obviously are available. That should be switched on at low level in your work area, and it will give you a very early warning if there's hydrocarbon leaking into the air. So that would be the second thing. And then the third thing, really, from the video is just to make sure that you have got all of the flammable refrigerant out of both sides of your system, both high and low side. Don't just take it out of one side, because if there's something like a block filter dryer or a block capillary, then you'll still have refrigerant left in the system. And if necessary, when you've finished what you think is removing all the refrigerant from the system, you've taken the system down onto a vacuum, you've backfilled with nitrogen, just make sure, by cutting the pipework if necessary, make sure that everything is out of that system prior to unbrazing.